All right, guys, what's up? I'm coming to you live from beautiful Morro Bay, California. We just had a fabulous day with family, and I'm definitely ready to talk about slope fields. And you guys should be excited because this stuff is crazy. It's actually pretty fun. So, if you remember the practice test that we took the other day, there was a couple questions I had you skip. This is what we're skipped, okay? Slope fields is kind of our last big topic before the AP test. All right, you guys, check this out. A differential equation, okay? A differential equation, which I'm going to call from now on like DE, right? Differential equation, is an equation that contains both a function, whoa, try that again, a function and its derivative, okay? Now, remember, typically like when we're talking about functions, you think way back before we did all this crazy calculus stuff, right? A function is something that's like, y equals in terms of x maybe. And its derivative is dy dx. So a differential equation is going to be a problem that contains a dy dx and a y. So, I mean, as an example, we can make these things as crazy as possible, like dy dx equals x squared y. All right, that's not that crazy. We could be like dy dx equals tangent to the fourth x y, something like that. All right, so you'll know it's a differential because it has a dy dx and it has an x and a y. Usually it has both. Sometimes it'll only have an x, sometimes only a y. Okay, now what we're going to do is we're going to graph slope fields. All right, this is actually pretty cool and something that you will often be required to do on the AP test. Okay, all right, so when I'm graphing a slope field, let's remember what dy dx means in terms of everything we've kind of talked about in the beginning when we were studying derivatives. This is the slope. Okay, and let's say it says, an example might say something like, sketch the slope field at the indicated points, and I have 12 points here that I need to sketch a slope field, right? It's like, what's a slope field? Okay, so here's how this works. Let me start with that point, because it's pretty easy, right? What's the coordinates of that point? That's the point 0, 0. Now, when I go and I plug this in, the slope at that point is 0. All right, and so I'd go here and I would draw a little slope of 0, but just like a little like dash basically, okay, a little part, because that'll say around there it has a slope of 0 at that point. All right, we're going to do that with every single point on here. Now, it looks a little intense, okay? You can definitely organize this a little bit nicer if you want. So for example, maybe I decide that I want to do it by making an x, y, dy, dx table or something to organize my work. I don't know, or you can just write it down, or you can do it in your head, frankly. All right, so let me start at the top. Let's do this. Okay, that's the point -1, 2. If I put that in dy dx, that gives me -2, -2, -4. All right, now let's think about how to draw that slope. Okay, so here are some slopes that we know. We've got, well, a slope of 0, which would look like that. Okay, we've got a slope of 1. So think about like things we know that have a slope of 1, like a graph, the line y equals x, right? It goes up 1 over 1. Up 1 over 1 would maybe just look like that, right? Kind of at like a 45-degree angle. A slope of 2, it would be a little steeper, okay? Now, I'm going to tell the difference between a slope of 1 and a slope of 2. You're really just kind of, drawing it. I mean, let's say it has like a slope of 10, right? That's probably steeper than that, to be honest with you. It's probably like that, but not quite straight up and down, okay? And then we have like negative slopes. What if I have a slope of -1? So in my slope field, it would probably look like that. A slope of -2 be like a little bit steeper like that. Okay, so you guys get the idea. It's very just I mean, you'll kind of see how it works, but it's very just kind of like drawing little lines and kind of guessing at the slope, I guess. Okay, so check this out. So I'm going to go through, do these. -1, 2 gives me a -4. That is a fairly steep negative slope, okay? Let me just do all the negative ones. -1, 1, -1, 0, -1, -1. Okay. So -1, 1 would be -2, minus 1, that would be -3. -1, 0 would be -2. -1, -1 would be -2 plus 1. That would be -1. You can kind of see, a lot of times you guys will see patterns with this, right? So -1, 1 is at -3, so it's not quite as steep. -1, 0 is at -2, again, not quite as steep. And then -1, like really kind of through there. Okay? All right, let's see. Now I need to let's move this out of the way so that I can make my table a little bit better here. Make this continue on down for days. All right. Let's do at 0. Let's do 0, 2, 0, 1, 0, 0, 0, -1. This one will be pretty easy to do because it's like my x's are all zeros. So 0 minus 2, 0 minus 1, 0 minus 0, and 0 minus -1 becomes 0 plus 1. So this has a slope of like -2. This has a slope of -1. This has a slope of 0. And then this has a slope of 0, -1 of +1. 0, -1. Oh, okay. I'm going to go with it. All right. Cool. And let's look at my next one. All right. In my next one, I have slopes of, let's see, this is at 1. 1, 2, 1, 1, 1, 0, 1, -1. All right. So for all of these, since x is 1, it's going to be 2 minus the y coordinate. 2 minus the y coordinate, that's 0. What's this one? 2 minus the y coordinate, that's 1. 2 minus the y coordinate, that's 2, a little steeper. And then 2 minus the y coordinate. 2 minus -1 is like 3, a little steeper. Okay? Look at that. That's a slope field, right? And that's literally all I'm doing. So I'm just drawing these little things, okay? Okay, if you guys Google Desmos slope field, is basically what I Googled, right? And the first thing that comes up is slope field generator, okay? It's kind of cool. You can kind of actually see. All right, so for this one, you know, just if you want to like take a look. So 2x minus y. Ah, interesting. There's my slope field. And this one actually has a point that I can move around. And you can see like, okay, so for example, as I'm going around the axis, this slope gets bigger, bigger, bigger until it's like almost straight up. And then it goes like kind of down to 0 and like that. But do you guys see that once you plot a ton of points, do you like see a pattern here kind of, you know? And so think of like a field for like, you know, the electronics are moving or something like that, right? And it can look like this, okay? So if you ever want to see and check kind of, you know, what it looks like, you can look at it online or something like that. All right, cool, cool. Here's a couple of tips for slope fields, all right? If the derivative is 0, we know that a slope of 0 is just straight across, right? If it's undefined, leave it blank. All right? So we don't want to draw it like up and down because that would be more like a slope of 100 or 1,000. If it's undefined, it just ceases to exist right there. All right? The big thing is going to be like look for patterns. That's going to be the big thing. So once I start doing this and I saw my pattern of, okay, if I pick, you know, -1 for my x, I'm doing this. If I pick 0 for my x, I'm really just plugging in, you know, the negative y value. If I pick 1 for my x, and I was like kind of figuring out what I was doing. So let's say we have a question that's like, let's do this slope field here. dy dx equals 2x. That's like, look at, what the heck? Look at all these. Do I really want to do this? Well, Okay, let's notice something real quick here. First of all, like one thing I notice, there is no y in the equation. All right, there's no y value. So what that means is, like, let's just start here. Let's start at x equals -3, which is like all those points, right? All those points. If x is -3, the slope is -6, okay? That's a pretty big negative slope. Like, that's pretty steep. I'm going to go ahead and do that on all of these. Okay, so even though it looks like a bunch of points, and it is, I just did 7, like really, really quickly, you know? And then let's say I want to use like another color, and I'm going to move over here to, actually I'll keep it on the same color for now. All right, -2. So if I go in to plug in -2, I get -4. Still a negative slope. It's just not like quite as steep. It's probably still steeper than that, but. Okay. Then I go and I plug in -1. So that's -2. It's getting a little bit less steep. And then I go and I plug in 0. Now this is cool because, so 2 times 0 is going to be 0. Okay? Makes sense? All right, so now let's go ahead and plug in at 1. So if x is 1, you know, so think about these points. It's like 1, 3, 1, 2, 1, 1. The x's are all the same value, so this is all going to be at like 2. So like not terribly steep. I'll probably make it a little less steep, but slope at 2. And then steeper, 4. And then steeper still, 6. And these are positive slopes. Okay? But guys, think about that. It looks pretty cool, right? There's my slope field. Okay, so what does this actually, like, what does this actually mean? All right, so let's find a solution curve, or sometimes called like a particular solution. Here's how you do this. You start at the point that you're given. We're going to start at a given point, and we're going to follow the slope field lines in both directions until you get to the edge of that part, okay? So, for example, let's look at the point 2, -1. Okay, so if I come up here, let me draw a nice color. 2, -1 is like right here, my slope field, right? Well, you see that up here, I mean, it's kind of like, I guess, like going that way, right? Down here, it's kind of going that way. Okay. And then it's sort of, I guess it's sort of like fades out, fades down, and then it, you know, if you feel like it connects, you could keep going, or if it stops at the end of the graph or whatever. All right. So that's called like the solution curve from that point. Let's look at the solution curve from the point 0, 1. Okay. Here's 0, 1. All right, in this direction, you guys see what's happening? It's kind of following the slopes that way. And from this direction, it's kind of like following the slopes that way. What does that look like? We know the graph of that, right? So this is the particular solution through the point 0, 1. Does that look like a parabola? Okay, and the equation of that parabola is x squared. And now that parabola is like moved up 1, actually. So it's like x squared plus 1. Okay. Guys, you ready for this? Ooh, this is so cool. Check it out. So this is, what's dy dx of x squared plus 1? What's the derivative of x squared plus 1? 2x. And that's what that was, right? And there's my slope field. Okay, let's do another one because that was so exciting. Let's see. Let's do the solution through the point 0, 0. All right. So here's 0, 0. So I'm just kind of like following the curves of these slope fields up. Looks like a parabola again. This time maybe a parabola that's just y equals x squared. But when I take the derivative of that, again, I get 2x. And so it's like, you know, no matter what it is, my derivative is going to give me 2x, but it's a slope field because, like, even this one, you know, maybe I could have, like, continued it on up like that. Okay, so it's actually really pretty cool. Let's go ahead and make this slope field just 2x. Nice, right? So you can see this, you can kind of see how this goes. So let's say I want to start at the point 0, 3, and I'm like following that, right? Does that look like it's going to be x squared plus 3? See how it just like kind of follows through that slope field like that? All right. Or let's say I wanted to start at like -5. You know? You guys see how it's like everything here is 0 and then it's like following through that slope field. Okay? So that's kind of what slope fields are going to help us be able to do. But a lot of times you have to like graph the slope field. All right. Awesome. So hopefully that kind of makes sense to you. Okay. Now we're going to actually work with this a little bit more algebraically. All right. A little algebraically. We're going to look at solving differentials by doing something called separation of variables. Okay. And kind of like wrote up your steps over here. Basically, what we want to do is get all the x's on one side and all the y's on the other side. Okay, now check this out. Let me just kind of... Okay, I've got a dy and a y right here. And I've got a dx and an x right here. Okay? So here's what I think I'm going to do. I want to move this y over here to where the dy is. And then I'm thinking I want to move the dx over here to where the x is. And then the 4, you can like leave it or move it. It's like completely up to you. Okay. Now the key is you can only use multiply and divide to get things over, never add or subtract. You're not allowed to do that. So for example, if this said minus y, right? I can't do like plus y to the other side. It just doesn't work because of the dy dx, okay? Okay, so check this out. So let's move this y over here. So this now becomes dy over y. Okay? And let's move this dx over here. So this becomes 4x squared dx. So now what I have is I have two equations, one in terms of y and one in terms of x. And so the next step, and this is like the key right here, you guys, is I'm going to integrate both sides. All right? I need to integrate both sides of this. So I'm going to go ahead and take the integral. So this is y with dy and x with dx. So we know we can take the integral of that. You can't take an integral of an x with a dy until you get to multivariate calculus. We're not there yet, right? Okay. Okay, let's check this out, like one thing at a time, guys. On the left, I have this equation dy over y. So let's think about how I integrate that. Well, think of this more as like 1 over y dy. Do we know what the integral of 1 over y is? We know that the integral of that is the ln of y in absolute values, okay? Then we go to the other side. Oh, sorry, hold on. Plus c. Then we go to the other side, and the integral of 4x squared is like 4x to the third over 3 plus c. Now, you guys, first of all, are these two plus c's the same thing? They're not, right? They don't have to be the same letter or the same constant. So maybe I could call it like C1 and C2. Okay? But then check it out. If they're just constants, maybe this is like a 2, that's a 5 or something. I don't know. I mean, could I not bring this one over here and just have like one constant to worry about? And maybe call this one, I don't know, constant 3 or whatever. Okay. Okay, so my point is, when you integrate, if you get like a plus c over here and a plus c over here, I mean, I can combine the c's because eventually if I have to find out what c is, that's fine. Right now, they're just both constants. So don't even worry about writing that c. Just write the one on like this side. So you don't have to be like C1, C2. Okay. So basically when you do this, let me go back a step here. When you do this, just don't put a plus c on one side, put it on the other side. Okay? Okay, so here we go. Now, the last thing is we got to solve for y. So we want to say y equals, because we want to get back to an equation, okay? So what we have to do is take this part of the equation apart one step at a time. All right, so we've got e to the and e to the, okay? Like the inverse of an ln is an e. E to the ln y, and then e to the 4x to the third over 3 plus c. Now the constant is still up in the exponent, okay? The constant's still up in the exponent. So the thing that's a little bit tricky on this one for sure is this like absolute value of y. All that means, if you do have like an absolute value like that, it just means that it could either be a plus or minus. So y is plus or minus e for x to the third over 3 plus c. And that is my equation. So that's solving the differential equation by separation of variables, okay? We don't know what c is. We're going to get to that in a minute. Remember when we first started doing integrals, how everything would have plus c, plus c. Okay, so you're going to have plus a constant. You know, it might be manipulated to another part of the equation. But right now, we'll just leave it as a plus c in there, okay, while we're practicing. Okay, nice. Let's check out this one. All right, separation of variables. Let's see. Okay, I got my dy and my y. So that's pretty easy. I can multiply the y over. And then I've got like my dx and all my x's, okay? So when I multiply this y, it'll say y dy. All right? Make this a little bit smaller because I'm writing too big. Okay, so this will say y dy. And then when I do this side and I bring that up there, it'll say 3x squared plus cosine of x dx. All right, so I just separate my variables, get my y's on one side, my x's on one side, and then what do? I integrate both of these, okay? Okay, so this turns into y squared over 2. This turns into x to the third over 3. The 3's cancel out. Okay, the integral of cosine is sine, and then I'll put a plus c right here. Okay? So now let's go ahead and solve it. I'm going to start by multiplying both sides by 2. Okay, so I get y squared equals... Now, I mean, you can distribute the 2 through there if you want. Or we can just be like... We can just leave it like that, honestly. And then, okay, I'm trying to get rid of a squared. I square root it. So I get y equals... Okay, now remember when you square both sides, you actually get plus or minus. So don't forget that. Okay, y equals plus or minus 2x to the third plus sine x plus c. I mean, be careful about trying to like simplify things too much. Just get it to the point where you've solved for y, and then you're like, boom, let's go. All right? Okay, cool. Let's look at one. Oh, no, 2 more. All right, sweet. 2 more differentials here. Okay. dy e to the y, right? dx sine 3x. This one's really kind of like cross multiplying, huh? If I just bring this up here, and I just bring this up here. Okay. That side looks pretty easy to integrate because the integral of e to the y is e to the y. So that's cool. Okay, over here, integral of sine 3x. Guess what we actually have to do on this? This is actually a u sub problem, okay? So let's move our way over here and let's do this. If u is 3x, du is 3dx. Okay, remember we go 3 1/3. All right, it's been a hot minute since we did u sub, right? And then this is sine u du. And we know that the integral of sine is negative cosine of u. And then we can go back in and put the 3x. So it's negative 1/3 cosine 3x plus c. Okay? So let's go put that over here. Negative 1/3 cosine of 3x plus c. And again, remember, I don't have to put a plus c here and a plus c here. It just doesn't, you know, I can just put one constant. So I'm chilling. And then you guys, how do I get rid of an e? So when I look at this, it's like, Okay, what is the inverse of E? E and what are opposites of each other? E and ln. Okay, so if I'm trying to solve for y right here, I got to get rid of the E. Well, I can do that by taking the ln of both sides. Okay, so I end up getting y is the ln of negative 1/3 cosine 3x plus c. So you guys, these are not necessarily giving us nice equations. I mean, they're ugly as heck, but we're able to solve them. All right. Now, you guys remember I was saying in the beginning, one of the rules is like you can only move things across with multiply and divide. You cannot add or subtract. So like if I tried to go plus x, x squared y, like that does nothing for me. That is not helpful. Okay. But here's a problem. See, I have an x squared there and an x squared there with my dx. But then I have like a y and my dy. Okay, so what are we going to do? Well, one of the things that's going to work with sometimes some of these harder equations is if we can factor it first, right? So let's take a look. Let's call this, again, still dy dx. I can take out an x squared. And now that that's multiply, I can separate the variables, okay? And so what I can do is my dx can come up here with my x squared. And my 3 minus y can come over here with my dy. All right, so this is what this is going to look like. Well, this side's pretty easy. That'll be x squared dx. This side will be dy over 3 minus y. Okay? Or, I mean, if that looks weird, for sure you can, like, write 1 over. All right? Okay, check it out. Let's integrate this. This is technically right here a u sub problem. All right, we're going to want to use u sub on this because, I mean, I can tell it's going to be an ln. And those of you that, if you're like really good and you're like, oh, I know it's going to be that. But there's a slight problem that you have to worry about with the u sub. So let me show you really quickly so that you guys don't forget this. So if u is 3 minus y, du is negative 1 dy. So I need a negative and a negative, right? So this actually becomes negative. All right. That all turns into du and u. Okay. Now when I integrate this, I can get negative ln of u, which is negative ln of 3 minus y. Okay, now my other side is super easy. It's just, x squared is x to the third over 3. That one was a lot easier. So that's x to the third over 3 plus a constant. Let's like take this apart one thing at a time. I'll go ahead and divide everything by a negative. I'm going to have to run up here real quick. All right. So I'm going to get ln of 3 minus y equals negative x to the third over 3 minus c. Now, you guys, is minus c still a constant? Yeah. So do I really have to put minus c? I mean, not really, except if you didn't, this turns into a different constant, and you kind of don't want to do that in the middle of the problem unless you're going to call that, okay, constant 1, constant 2, So I would just treat it like it's a variable and don't, just undo the equation one thing at a time, okay? Okay, how do I get rid of an ln? Well, e to each power, right? So this is, oh gosh, absolute value. 3 minus y is e to the negative x to the third over 3 minus c. Getting that out of absolute value, plus or minus e to the negative x to the third over 3 minus c. Okay? Subtracting 3 from both sides without rewriting it. I'm just going to do that. And dividing everything by a negative. Holy cow. Well, plus or minus divided by negative is still plus or minus. I guess it's like minus plus. But we can still just write plus or minus. Plus 3 because I divided everything by a negative. All right? Okay. One last thing that we're going to talk about real quick here, okay? All right. So with finding the C. So we're basically trying to do this when it says find the particular solution. This really means find C. Because, you know, a slope field gives us a look at what the general solution looks like all the solutions as they go through the slope field, okay? The particular solution is what I give you at this exact point. I want you to tell me what equation it goes through, right? Okay, so we're still doing our separation of variables. All right, so check it out. I've got 2x dx. I've got y squared dy. Okay, so dy over y squared is 2x dx. Okay, let's integrate this. Now, do you guys remember? Let me just do this off this side. The way I integrate y squared. Okay, it's y to the negative 2, which becomes y to the negative 1 over negative 1. All right, which becomes negative. You can put the negative wherever. And then remember that the y moves back down to the bottom. Okay, so that's negative 1 over y. 2x, the integral of that is just going to be x squared plus c. All right. Now, before I start like manipulating this thing like crazy, the second that you actually take the integral of both, this is the point at which you should find c. Okay, before it starts getting like all crazy. All right, check this out. When y of 1 equals 2, what does that mean? Well, if I were to interpret this, it means like when x equals 1, y equals 2. Okay? Let's go ahead and plug that in over here. When x equals 1, y equals 2. Now, can I solve that for c? Well, negative 1/2 is 1 plus c, and if I subtract that over, negative 1/2 minus 2/2 is negative 3/2. That's c. Okay? So, I'm going to go into this equation. I'm going to put my c that I found right here. And then I'm going to continue solving this, okay? Let's go ahead and divide everything by a negative. So 1 over y is negative x squared plus 3 over 2. And then how do I make 1 over y into y? Okay, this is kind of the shortcut way to do it. I just reciprocal that. I just flip it. And I flip that. The problem is that some people are going to try to flip these separately. Can't do that, right? Picture that whole thing over 1. When I flip this, that side will be y. That side will be 1 over negative x squared plus 3 over 2. Okay? Is it an ugly equation? Absolutely. Right? But we got to that. We got to the point we needed to get to. Okay? Okay, sweet. Let's try another one here. Find the particular solution when f of 0 equals 4 dy y dx x. Okay? Separating these out. Y dy equals e to the negative x plus 2 dx. Okay, integrate this. Y squared over 2 equals, now, technically, you guys, this is a u sub. This is a u sub, okay? And technically what we would do is we would go, u is negative x, du is negative dx, negative, negative. Really, the only thing that's going to happen, if you can see this, the only thing that's going to happen is this outside negative. So it's going to be negative e to the negative x. Okay? It puts that extra negative on the outside. Okay, and then the integral of 2 is plus 2x plus a constant. This is the point where I'm going to try to find c. Okay, before this gets totally away from me, right? Okay, now this tells me that f of 0 is 4. What that means is when x equals 0, f of x equals 4. And what's another name for f of x? That's just y. Okay. When x is 0, y is 4. So here we go. 4 squared over 2 is negative e to the negative 0 plus 2 times 0 plus c. Okay, 4 squared is 16 over 2 is 8. E to the 0, anything to the 0 is 1. Add the 1 over to the other side. C equals 9. All right? Okay, so here we go. Let's write this over here. let's say y squared over 2 is negative e to the negative x plus 2x plus 9. Multiply everything by 2. I mean, distribute if you want, but you don't have to unless it was a multiple choice question. You'd see if they distributed or not. And then my last step, square root both sides. Okay? So y equals plus or minus square root of 2 negative e to the negative x plus 2x plus 9. There we go. All right? Cool. Let's look at this last one here. Let's separate this bad boy. Let's see. dx with x, right? dy with y. Okay. When I separate this, I'm going to get dy over the square root of y, and then x to the third dx. All right? Okay, now let's remember how to integrate 1 over the square root of y. If I bring that up, that's y to the negative 1/2. Okay? Negative because it was on the bottom, 1/2 because it's the square root. When I integrate that, I add 1. So I get y to the 1/2 over 1/2. And you guys remember, instead of going y to the 1/2 over 1/2, we go y to the 1/2 times 2 over 1. Okay? Now x to the third, that's going to be x to the 4 over 4 plus a constant. Here we go. Okay, my constant. This tells me that when x is 2, y is 1. All right. 1 to the 1/2 is 2 to the 4th over 4 plus c. Okay, remember 1/2 means square root. The square root of 1 is 1. Okay, 2 to the 4th is 16 divided by 4 is 4. So c is negative 2. All right, so here's my equation. Put this in right here. 2y to the 1/2 is x to the 4th over 4 minus 2, because c was negative 2, okay? Divide everything by 2. Now, you guys, you can literally, if it's a free response question, just go over 2. Like, you can do that. That's fine. If it's multiple choice, they probably would do something more like this. If I divided the first part by 2, that would go to over 8. And if I divided 2 by 2, that would be 1. So that might be how you would see it. And then my last step here, how do I get rid of y to the 1/2? Remember, that means square root y. What's the inverse of a square root? Squaring both sides. So I end up getting x to the 4th over 8 minus 1 squared. Okay? All right, pretty cool. If you took the derivative of that and simplified the absolute heck out of it, you'd get x to the 3rd square root y. You know? Okay, awesome. Let's see what we got here. Okay, you guys. So for the last little part of your classwork, what I would like you to do real quick is, this is on Canvas, go to the Desmos slope field activity. And I want you guys to do that. Now I'm actually going to be grading this, like, don't just rush through it. Actually do the questions as if you were on, you know, the AP test or something. So this is on Canvas. When you click on it, it's going to look something like... Okay, so I'm going to give you guys something on Canvas that I want you to work on. Let's see here. If you... I'm trying to get this up here. Ah! What a cute little pony. Okay. Is that a pony? I don't know, man. Hey, let's go. All right. I'm going to put something on Canvas. It's called the Desmos slope field activity. This I would like you to do in class when this when you guys are done with this video and taking notes. Okay, this will be your homework for 10.1. All right. I'm going to take you to a page that looks like this. There's like 6 slides, so it's basically like 6 problems. Okay, and I'm going to come through and I'm going to like grade these too. So make sure you guys are actually doing this. So this slope field shows all the solutions for dy dx equals negative x over y. Why do we say it shows all possible solutions? Just give it your best answer here about what you think, why this is showing possible solutions, okay, through this slope field. Same slope field now. It says, okay, we put a point at negative 3, 4, representing the initial condition. Sketch through this point. You guys will notice that when you put this on the graph, okay, it's going to be a little thing that you can sketch. Sketch through that point and see if you can, like, right, treat them all like a little wind pattern. Which way is this line going to be going? Okay. Okay, here's another cool differential. Now, I would actually like you guys to do a little bit of work on slide 3. Okay, so on slide 3, I would like you to get like scratch paper or something and actually do a differential on that. Now, there's no y's, there's just x's. So what I'll do is I'll take this dx, multiply it up there, and integrate both sides. But with the initial condition, you can find c. Okay, so I'd like you to do that and then kind of take a look. I want you to trace over here too, how that follows the slope field and see how that compares to the answer you got, right? So type the exact solution, but you got to do a little bit of work on there, just on like some scratch paper or something. Okay, or on the back of your notes or whatever. This one, you're not going to be able to separate and do this on your own. Like, you're just not. Because of the minus y, you can't separate the variables on this, right? But it just is basically, use the sketch tool to point out regions where you see a connection between the differential and the graph. For example, we're looking at patterns. So what happens when x is 0, for example, right? What happens when x is very large? What happens when, you know, y is 0? Like stuff like that, and then kind of like, you know, talk about it, point it out on the graph or whatever for that. Okay? And then, all right, this will be like kind of interesting, matching the slope fields with this. Just take a look. Now, how are we going to do this exactly? Well, if you click on it, it'll go a little bit bigger. That is so trippy. Oh my goodness. Check this out. It's like, it starts at maybe like at the point 1, 0, it looks like a slope of like 1. But then as it goes to 1, 1, 1, 2, 1, 3, okay, it's getting really, really steep. So what this is showing me is that the bigger y gets, the steeper this gets. So like what could kind of go with that? The bigger y gets, the bigger the slope gets. I mean, that one maybe, right? Y gets big, the slope gets really big. That one doesn't even have a y. Not really that one. Not really that one. It's when as y gets big, the slope gets really negative. And like a cosine one. So I'm kind of feeling like it's that, right? Just kind of do your best. I mean, look at this. What do you guys see when you see that? See like kind of wavy, I don't know, like a sine or cosine graph maybe? Okay. So just kind of do the best you can, just kind of looking at these slope fields and either taking a look and going like, okay, in the third quadrant, they're all positive. What kind of thing would give me that? In the second quadrant, they're all negative or whatever. All right, and then the last one, you guys, I want you to do a little bit of work on this because this is typically, if you do have a slope field differential equation on the AP test, part A is typically this, right? So let's just kind of remember how to do it, and I'll be checking out your sketches too. I'll be looking at this, but -1, 2. -1, 2. So have some scratch paper or whatever. X is -1, and that's 2. That's going to be 4 minus 1. That's going to be 3. So I need to make a slope of like 3. And then just go through and do, you know, your slope on all of those. All right? And then at the end, you can submit that so that I can go and give you guys points. So that'll be like the end part of the classwork for this. Okay? Now, from here on out, for the rest of the time, every day I'm going to give you guys a homework, but it's going to be either a practice FRQ or a practice multiple choice, okay? So I'm not sure which one I'm going to post for tomorrow, but I'll post something for your homework that's going to be like a practice FRQ, and then we can go over that next time, okay? All right, super sorry I can't be with you guys, but hopefully you understood this lesson, okay? This is pretty important stuff. Work on that decimals activity, and then you can get started on your homework. All right, thanks. Have a great day, guys.